Another tool that is sometimes used is called Payback Period. Now, we won't talk about Payback Period too much, and we won't use it a lot in this class because it has very obvious pitfalls. So let's talk about what it means first. Payback period is, well, first of all, there's two kinds of payback period: simple payback period and discounted payback period. The simple payback period is the number of years required for cash inflow to be equal to cash outflow without taking into account the effects of compounding. So it is a measure of liquidity rather than a measure of profitability, and therefore we're talking about cash in without considering compounding, as I mentioned, which means, let's say that I made an investment of $1,000 and each year I'm getting a benefit of 200. That means that my payback period is 5 years. In 5 years, I will make back my $1,000. Speaking of simple, straight up cash per year without taking into account the effects of interest. So what is the downfall of this? Well, obviously there's a big chance we're actually going to get it wrong because it is really not taking into account all the stuff that we've been talking about in this class. All it wants to know is, when am I getting my money back? And you might be thinking, well, why do we even talk about it then? Because sometimes that's the only thing that matters to someone is, I want to judge projects based on how fast I'll get my money back. And that's fine, but you might choose one of the options that doesn't give you quite as good of a present worth, for instance. So payback period is the smallest value of theta. They use theta in this book, which has to be less or equal to n, for which the relationship below is satisfied. This means that the summation of my receipts minus my expenses minus I has to be greater or equal to 0, and we do have a discounted payback period, which we talked about a second ago. What it means is, this one we will take into account the effect of compounding by getting those cash flows into some sort of form like present worth or future worth. Present worth is usually the most conventional, and then seeing when you get your money back that way. This makes a lot more sense, and this is called theta prime in this notation. So again, we don't know anything about the project desirability except the speed at which the initial investment is recovered. So the recommendation is to use payback period only as a supplemental information in conjunction with one or more of the other methods in this chapter. So say present worth, and then you have two. You may have you're comparing 3 options, and 2 of the options are really close in present worth. Then maybe you might look into payback period, and the one that gives you your money back sooner so you can reinvest it, that is the better option. So let's look at this example here. So we have a cash flow in this format, in table format, where we have end of year for 5 years. We have a net cash flow, which just has money coming in and out, and then a cumulative present worth at 0%, meaning it's not really present worth, or it is, but at 0%. All this is 42, and then 42 plus 12 is 30, 30 plus 11 is negative 19, negative 19 plus 10 is negative 9, negative 9 plus 10 is 1,000, right? However, I could also have another column here where I get the present worth of each one of these cash flows, and then I get the cumulative amount here. So if we go down here, when am I going to recover my 42,000? So by the end of year 1, we'll have negative 30, then negative 19, then negative 9, and by the end of year 4, we will have gotten back our money. So theta here is equal to 4. Whereas once we discount the cash flows, it actually takes a little longer. It takes all the way till year 5 to get that money back. Here we have another example. The cash flow for 3 alternatives, the cash flows are as follows. So each one of these we could actually cram here a little running total, or a cumulative, sorry, I lost my words there. So negative 500 plus negative 400 is negative 900, and then plus 200 is negative 700, plus 250 is negative 450, plus 300 is negative 150, and then plus 350 gives me 200. So this gets paid, or you get your money back sometime during year 5. And this is simple, so this is a simple payback period example. Okay, and then we can have here negative 600 plus negative 300 is negative 900, plus 350, negative 550. Here we have negative 250, and here we have 0. So this was year 4. And here negative 900, we continue with negative 900, negative 700, 500, 300, 100, and finally 100. So here it happened year 6. So if we base our decision solely on simple payback period, my decision should be B. However, if we use present worth analysis, and I ask that you do this on your own first, try to see what you get and which is the best alternative. So if we do this, and I don't have space here, so let me, let's check. Did I leave a, oh yeah, I left a blank slide. So, and let me get out my notes so that I can do this example. Oh, I actually don't have it all worked out. At least I don't see it. Oh no, here it is. Okay. So for this payback period example, for A, if I try to find the present worth is going to be equal to negative 500 plus negative 400 plus, okay, so what I'm going to do here is I am going to find first the present worth at period 1, and then I'm going to bring it over for 1 period. So why am I doing this? There's a very pretty gradient here, right? So what I'm going to do is when I calculate gradient, it's going to put it in year 1, and then I'm going to take this and I'm going to move it 1 period backwards. So I can take advantage of that beautiful gradient. So plus 200, P given A, 12%, 5 years, plus 50, P given G, 12%, 5 years. And then this I'm going to multiply times P given F, 12% for 1 period. And that gives me 72.179. Okay, let's do it for B. For B, I am going to do something similar, but I'm not going to do it to take advantage of a gradient. I'm going to do it because I have that year that has that 0. So negative 600. Oh no, that's C. This one also has a gradient, but the gradient is decreasing, ignoring this from here to here. So again, I am going to take advantage of that by doing the following: plus negative 300 plus 350, P given A, 12, 5, minus 50, oops, P given G, 12%, 5, and multiply that times P given F, 12% for 1, and this gives me negative 26.81. So remember, that was our choice. That ended up being a bad investment. And for C, negative 900 plus 200, P given A, 12%, 5 times P given F, 12% for 1 period. This gives me Negative 256.25. So the obvious choice was A. There we go. Oops. Okay. So you see why using payback period is not always the most convenient option. But it can help in some situations, sort of as a tiebreaker, for example.